Okay, in this video we're going to wrap up bond pricing, and we'll start with looking at a couple of examples here. First, what is the price of a bond that has a 6% coupon rate, matures in 11.5 years, and has a discount rate of 4.21%. So in Excel we would use the PV function, type in 0.0421 divided by 2, have those other entries there in the function. We'd get an answer of $1,161.85. In the financial calculator, we would have this series of inputs, and let's just go to Excel in the financial calculator and put this stuff in and just see how we get $1,161.85. So I'll first go to Excel. Up here in the top left, we're solving for the present value, but let's put in all the things we know. The future value is $1,000. That wasn't given in the problem, but it's our default assumption, recall. The number of periods, it's 11.5 years, but we have 2 periods per year because, again, that's the default assumption. 2 6-month periods in every year. The periodic rate is 4.21%. We're going to divide that by 2 to get a periodic rate of 2.105%. And then the periodic payment is going to be equal to $30 per period. So a 6% coupon rate means $60 per year. Divide that by 2 and we would get $30 every period. So if we solve for the PV, we're going to have the rate here, the number of periods is there, the payment is down here, and the future value is there. We would get this price. It's a negative number, $1,161.85. Again, that indicates that we would have to pay that amount of money for it. If you wanted things to look a little bit cleaner in your spreadsheet and you put a negative there to flip the signs and get a positive number for the value of the bond, that's fine as well. I'm kind of indifferent to the signs, especially for the final answer. Signs are very important in the calculations. If you get your signs wrong, it's very likely that you'll get your answer wrong. But for simple problems, this kind of thing is just fine. With the calculator, let's look at those same inputs here. We want to clear out the inputs, and we'll put in the number of periods is 11.5 times 2. So 23 total periods. The interest rate is 4.21. Divide that by 2. The cash flows are $30 each. The payments, and then the final cash flow, the future value lump sum is $1,000. We compute the present value, $1,161.85. All right, let's look at the second problem here. Back on the spreadsheet, we've got a 0 coupon bond that matures in 25 years and a discount rate is 5.92%. So with Excel, we're going to have these inputs, financial calculator, these inputs. Let's just go and take a look at those. And I do want to make an important note here that we need to adjust the periods to be 50, right? 25 times 2, 25 years. And our default, even with 0 coupon bonds, is that there's 2 periods per year. So we're going to have 50 total periods. The interest rate is 5.92. We're going to divide that by 2 to get a periodic rate. There's no periodic payment, no coupon payments. And then the future value is $1,000. So if we solve for the present value, and I'm just going to actually copy that formula over here, we get $232.58 as our price. With a calculator, we can put in the different pieces that we need. No payment, $1,000. Future value, the interest rate is 5.92 divided by 2. And then we compute the present value, negative $232.58. Again, we change the sign here. So all is good. Those are very straightforward, very easy calculations. So we can move on in our slideshow here. And I want to look at some bond pricing functions. In Excel, there's a couple of important ones. The price and the yield function, we'll take a look at each of those in turn. So first, the price function, it returns the price, and this is an important distinction about this particular function. It's expressed in percentage of par. So be really careful whenever you're doing your inputs and interpreting your results. So it's the percentage of par based on the following inputs. So the first argument in the function is going to be the settlement date, that is when you purchase it. The second argument is the maturity date. Third is the rate, so the coupon rate. That's expressed in annual terms, so we're not going to put in the periodic payment amount, but the annual payment of the coupon. The yield, again, is expressed in annual terms, so this would be the discount rate that we would use. Redemption is the amount collected at maturity, and this is very important. It's expressed in the percentage of par, so typically that's going to be 100. The frequency, the number of coupon payments a year, so for our default assumption is 2 there. And then we're generally going to ignore this very last argument, the basis, where we have this optional thing that has a code. It's a dummy, I think 0 through 4, that tells Excel how the days are counted. We're just going to keep it simple and ignore that one. So let's go to Excel real quick and take a look at an example of the price function. Here we go here. I've got some inputs, settlement date of January 1st, 2018. I've made this a 6-year bond, and I have pushed the settlement to be 6 years later exactly. The coupon rate is 6%, the yield is 5%, yield of maturity is 5%. Redemption, we're going to get 100% of par at maturity. There's 2 periods per year, and we're going to ignore the basis, or if we put in 0, that's the default. So if I go up here to the price function, and I link to all those pieces in order, hit hit the enter, I get 105.1289. That's expressed once more in percentage of par. So to get the price of the bond, I would multiply that times 10, which is what I did here, and I would get a price of $1,051.29. Now I just want to show you that that's exactly what we would get if we did the calculation with the time value functions, the present value function. So first it's the periodic rate, 2.5% per period. That's the discount rate. The number of periods is going to be 6 years times 2 periods per year. The periodic payment is $30 because we have a 6% coupon. 6% of 1,000 is 60 per year. Half of that is 30 per period, so that's what we put in there. And then $1,000 is our future value. So either way, we get the correct answer, the correct result of $1,051.29. That is the price function. Next, let's look at the yield function. So the yield function is going to return the discount rate, the yield to maturity, or depending on the context, it might be the yield to call or various other yields that we could be interested in. The arguments are going to be very similar to the price function. So we have the purchase date, the maturity date, the coupon rate, again expressed in annual terms. There's a PR if you're looking in the kind of the description of the arguments in Excel. That's going to be the price. That again, that's expressed in percentage of par. Redemption is the amount collected at maturity, expressed once more in percentage of par. And then the frequency and basis, just like with the price function. So let's go ahead and look at yield. That's over here. So I'm just going to actually use the inputs from the price that we calculated and stick that into the function, the yield function, and see if we do indeed get a 5% yield to maturity that we ought to be getting. So I've got all the same information, the same coupon rates. Now the price, you can see that I've linked over to the price that we just calculated. The redemption is going to be 100% of par. And so when I compute the yield and put in all the pieces where they belong, I get 5.000. Indeed, that is the yield of maturity that it should be. And then there's another function we could use in Excel. This is the simple time value function where we solve for the periodic rate. Here my inputs are going to be the 6 times 2 for the number of periods. Let's click on that. The number of periods. The payment is $30 per period. The present value, I linked to the cell over there actually, and I multiplied it times 10 to get the dollar amount. The $1,000 future value, the par value of the bond, and then I'm multiplying all of that result times 2 to convert from a periodic rate to an annual rate, and that's how yield to maturities are always expressed. We would talk about yields in annual terms, so I'm multiplying it times 2 and we get the exact same result. So 5% is the yield to maturity if we're buying the bond at 105.1289% of par and redeeming it at par if it's a 6% coupon rate, 6-year maturity. So that is the price and yield function. And actually this won't be the last video. I'm going to pause now, stop now, and we'll come back in the next video and we will wrap up the pricing of bonds. So I will see you then.